me from where this engineer was coming. Okay? So the idea is that, as Herophilus already knew, medicine has a strong component of mechanics. So I decided that our community needs an interaction with this other scientific group, also in the hope that we manage to persuade some doctors to spend some time in research instead of doing surgery all the time. Okay, so the presentation of today will be directed, the spirit of them will be, they talk to us, trying to communicate us some of their scientific problems. Right?
Exactly.
Okay. I don't see your colleague who came here with pictures with blood everywhere. He's coming. Okay. So we will need to be ready also to these pictures. By the way, I was teaching 3 years in orthopedy school at the beginning of my career in Napoli. And I remember that for frightening me, they came to my lectures with the white, I don't know how to say in English, the white coat with blood everywhere. They wanted to frighten me. Okay. So please.
Thank you very much. So good morning, everyone. It's a great pleasure for me to stay here with you. I am Gabriele di Carlo. I am an orthodontist. I teach at Sapienza, University of Rome, a couple of hours from here. And I happy to start this presentation about our field. Thanks to Michele and thanks to the professor for the invitation. Just to explain you what is our job and what is the problem that I met during my career into research. So, as orthodontists, we deal with biomechanics. And this is particularly true when we deal with adult patients. So, we basically move teeth. So, and we need to know biomechanics to do so. But when we treat children, it's not only by moving teeth that we address our treatment. But we need to know and communicate with something that is dynamic. And what is dynamic is the craniofacial growth. So we are not only moving teeth, we are trying to fix abnormal craniofacial growth. And in our job we have, let's say, 3 scenarios that we classically call class 1, class 2, and class 3. Okay? This is actually linked to the relationship that exists between the maxilla and the jaw. So, when we have a neutral relationship, let's say this is the maxilla and this is the jaw, okay, we talk about class 1 and we consider that normal. Okay? When we have the jaw that develops back compared to the maxilla, we are in class 2. Okay? So it's maxilla and the jaw ends here. Okay? So there is this gap that we actually call overjet. The last class of malocclusion we treat is class 3, when we have the, let's say, the maxilla and the mandible that develop forward. Okay? So we have a negative overjet. This is actually, can be, this classification is a classical scenario from the beginning of the last century. Okay? So, when we use our appliance, what we are trying to do in a simplified manner, we are trying to push class 2 and class 3 into this pattern, the normal pattern, the class 1. So we use appliances that, as I said, that don't only work on tooth level, but they work at the bony level. Okay, so the biomechanics start to be a little bit more complex. And this happens into a system which is dynamic. But the system is extremely complex, we will see. Because we have to deal with a genetic component, we have to deal with the role played by the musculature, and we have also to deal with function. And extremely relevant is the role played by respiration. So typically, the researchers in the last century were only focused, of course, it's not their fault, but they only focused in a simple mechanism, in a simple theory that is able to explain the entire process in a very simplistic way. They explain a lot of mechanism, but they fail into the research of the key to modify growth. So far, we can stimulate growth by means of appliance, but we cannot modify growth. So we cannot do this. This is extremely difficult to make it happen. Sometimes happen, sometimes you have the feeling we don't know why. Or let's say, we don't know the mechanism which is behind it. Okay? Because by using the classical theory, we cannot find an explanation. So, let's go. So, another feature of the classical researchers was that they were mainly concerned about the postnatal period. So, majority of the studies were made in the postnatal period. Something started to change with the introduction of discovery of home-box genes and growth factors. In 2005, it was clear that the mechanism of growth which were controlled by a sequence of genes which was called home-box genes. And this is a particular, let's say, weird sequence of genes because they can be influenced by the environment, they can be influenced by themselves. So this sequence of genes, they have a regulatory mechanism inside. Okay, so of course in the past century it was very difficult to explain something using a single theory because there was this underlying mechanism behind that it's already complex on itself. And home-box genes play a very important role in define phenotypes, in define patterns of growth in every single part of our body and specifically for the craniofacial complex. So, thanks to this, in 2005, we were trying to influence growth by means of growth factors. We were trying to modify the gene sequence in order to get what? To get the class 1, let's simplify, to get the normal pattern starting from an abnormal pattern. So typically, the growth theory were basically understand as a balance between genetic and epigenetic, between what was inside us and what was happening around us. Okay? And what the idea was to try to modify them by means of growth factors or trying to activate or inactivate the regulatory sequence of the home-box gene. As I told you, there are two features, muscles and respiration, that play a very important role on it. So, these three patterns actually recognize a different muscle organization. So, in terms of vertical dimension, we talk about long face and short face. Typically, the short face, they are very, very strong muscles, very active muscles. And the long face tend to have a very thin muscles. Or let's say a more variable pattern of musculature compared to the short face. So that means that there is an epigenetic milieu in which if we can stimulate the muscles to play in a strong way, then probably we can go from the long face to the short face just by means of exercise or growth factors. And the idea was, okay, so let's start from the IGF-1 to promote muscle growth, then bone formation in order to change our pattern. And the IGF-1 insulin growth factor seems to be a very promising factor because the IGF-1 can increase the protein synthesis and the muscle mass, and at the same time can activate the reparatory mechanism that produce muscles, fibers. So we started to use IGF-1 in vivo. Not, it's not possible because it's at this point it's dangerous, but in animal models, in order to change the pattern from the long face to the short face. Okay? So, by means of stimulating the hypertrophy, the idea was to basically change our life as orthodontists. We were not longer using appliance, but the idea was to use injection to change the face of our patient. That was the idea in 2005. But there were a lot of problems. So first of all, the injection of IGF-1 in the systemic way, it was a bit dangerous in terms of development, but at the same time, it was also difficult to reach the necessary quantity of growth factor at the level of the muscle. So, as a second attempt, they tried to stimulate the production of IGF-1 into the muscles. And it was a nice idea to create a viral administration of cDNA encoding for IGF-1 at the level of the bone, at the level of the muscle. But that produced what? Nothing. Because that was 2005, now we are in 2025, and we are still using appliance. We are not using injection to treat our patients. So, as you can see, from the theoretical point of view, everything seems clear. We have to change the muscles in order to change the face, but this airplane does not fly, even though theoretically it can fly. So there should be something missing. So growth factor theoretically works, but in reality they don't. Let's see what happened in terms of respiration. So back in the 70s, as you probably some of you remember, the doctors, the dentists, they were promoting the use of adenoidectomy in order to change the way of breathing. Because by changing the way of breathing, we were able, the idea was to change the face of the patient. Because when we have an oral breather, and this is the typical pattern of the oral breather, the typical face of oral breather, so which has the vertical dimension extremely developed in this way. So you can see that the mandible goes back. Okay. So when we breathe by means of the mouth, we tend to have a posture that stretch the muscles in order to let develop the mandible and the entire craniofacial complex in this way. This is called the soft tissue stretching hypothesis. So we have to breathe by means of the mouth, and all the muscle push back the mandible and influence the growth of the bone. And that was a paradigm that worked for 40, 50 years. And it is true. This is a passion of mine that if you can see, I didn't use an appliance, I just trained muscles, and I changed a little bit what was the position of the mandible. I changed a little bit the face because I trained the muscle to try to correct the line of growth of the patient. You can see here.
Sorry, how you correct this?
This I use a myofunctional exercise. No appliance, just exercise every day. So by doing gymnastic of the muscles.
So you didn't cut on.
This patient was a patient which was candidate for surgery. But she had a problem here, she had no bone here. So by using the classical appliance, we start to have periodontal problem because typically we work with limits. We have an anterior limit. Oh, sorry, I closed everything. Okay. So we have here an anterior limit. So if I use an appliance, for biomechanical reasons, here we have a curve. Now you cannot see the curve, maybe a little bit here. So if I use a night-eye wire, I compress the wire correct the teeth in a way that the tooth goes out of the bone. So for that reason, I had to find a different strategy, okay? And probably, at the end, probably she will do surgery, but it was not possible at that time because she had some problem of periodontal and bone dehiscence in the anterior part of the dentition. So, exercise every day, 3 sessions, repetition of 20 for exercise, 20 times for exercise. So we change the tone of the masseter muscle, and this helps to correct a little face. The problem with this approach is that it's not reliable. I mean, we found some good results in some group of patients. In some others, we don't find any kind of results. And this is why the mean of this presentation is there is something complex. There are interactions that probably we don't see. And the dynamism is very important in respiration because when we breathe by means of the mouth, we don't only breathe by just keeping the mouth open, because we can also breathe by opening and closing the mouth rhythmically. And that guides to development of a different scenario, because if we breathe by keeping the mouth open, then we stay like this, and we have that scenario that I presented before. But if we open and close, we do gymnastic, and we have a short face. So, it's true, muscles can influence the growth. In how many ways? 1, 2, so far I talked to you about 2 ways. I made different studies, okay, back on the old days, I would say. And the first study I made in my PhD actually was I tried to define which was the relationship between the craniofacial complex, so the 3 class, and the dimension of the airway. So I made a 3D reconstruction by means of DICOM and 3D software reconstruction, Linux. And, okay, this is the study of it. And I reconstruct, there is an image, okay, this is what I did. So this is the craniofacial complex. This is let's say, this is the typical class 1, so this is the normal complex. So just to repeat, class 2 is when we have the mandible back, class 3 is when we have the mandible forward, okay. So we believe that the dimension of airway plays a sort of a role. So what I wanted to investigate, it was if the total volume the partial volumes of the airway were in a way linked to the craniofacial complex class 1, class 2, class 3 pattern of malocclusion. So this is our study, and that was a static study, it was not a dynamic study. So, and I found, surprisingly, that in reality, it seems that the dimension of the airway, they are not linked to the craniofacial complex. So, we see from the clinical practice that the dynamism of respiration can change a malocclusion, but the airway per se, studied anatomically, so basically I measured all the dimension of the craniofacial complex and all the dimension of the airway, and I made a correlation, a simple correlation. There was no correlation between the three scenario and the airway. Then I said, okay, let's use our appliance to promote modification of the bony maxilla and jaw and see what happened at the level of the airway. And I found that especially for the lower part of the airway volume and the total volume in total, I was able to create modification of the airway. So basically what happened was, let's go here. So this is a pre-treatment patient. This is a class 2. The mandible is back behind the maxilla. If I use an appliance, I can get a class 1 with increased dimension of the airway. And it seems that we can also change the posture of the patient. So there is no link, but if we use appliance, we modify the craniofacial complex and the airway. So where is the link? Okay, so this is. So my idea was that we were trying to see the reality by means of a very short window. So we, as orthodontist researchers, we are studying only the macro scale. But the reality of the system is that we have the micro and the nano scale. We have, do you remember, we have the genetics. We don't only have the muscles. So we cannot only study the craniofacial complex by means of linear measurements. We need to find the tool to put all this information in our Caesar salad and try to find answer for what is growth, and try to find the sacred graal of growth. How can we modify it in a reliable way? So my idea was to study craniofacial complex by using network analysis. So many of you maybe know network analysis or complex system. So these three, 1, 2, 3 are 1, 2, and 3. So these are craniofacial complex explained by using network analysis. And from the topological point of view, you can see that the class 1 and class 2, they are pretty similar. But there are some points in class 2 in which there are a hypercorrelation between nodes. Okay, the red dots are anatomic measurements, functional measurements, okay, muscular tone, muscular width. Okay, so by means of network analysis, I was able actually to visualize this. Okay, and when we go and watch what is here in this hyper-interactive node here and here, I could see that those nodes are nodes that we actually try to fix while we use oral appliance. Indeed, if we fix them, if we solve this hyper interconnection, then we get a network as a class 1. Okay? And I wouldn't say surprisingly, but it was very interesting to see that the class 3 patients, they have a completely different network. So all the anatomic landmark, all the muscles, all the functions works in a completely different way. So probably the real malocclusion is only 1, not 3, as our valuable historical professors
Sorry,
told
so
us.
you claim that it is easier to change a class 2 into class 1?
Yes.
This is true clinically?
I would say yes, because typically class 3 patients, majority of them, they are surgical. So something that they are surgical patients.
Oh.
So something that highlight our limits as orthodontists. I would say that in the clinical reality, there are not too much difference in terms of craniofacial complex between class 1 and class 2. So what is different is the organization of teeth compared to this craniofacial scenario. Of course, there are limit conditions. There are class 2 which are very severe, okay, that they are closer to, I would say, a syndrome than of alteration of normal growth. But typically, class 3 seems to be the real problem. And this is true in our community. When we have a class 3, we always say to the parents, listen, this could be a genetical problem. We say genetical problem. Maybe we should be much more comprehensive to explain what is behind that, because it's not only genetic, in my opinion. But we say, this could be a genetic. We use the appliance, we see what happens. Maybe we correct, maybe we don't correct. But there's a study on that.
I know that doctors say all the time this.
Because of lawyers. It's not our fault. So class 3 tends to have this behavior, okay? And this was true in that study. Okay, this is Barabasi that actually explained us that the interaction between nodes can play, let's say, a super role by changing the development of craniofacial complex. So at that point, I decided, okay, now I will apply the network analysis on my first study of the PhD, in which I found there was no difference between class 1, class 2, and class 3. In that original study, I approached to malocclusion by studying 3 scenarios, so 1, 2, 3. I made, with exactly the same database, a community detection analysis at this time. The first result I got is that I have 5 community. So the malocclusion are not 3, are 5. This is, I'm talking about point B. As you can see here, 1, 2, and 3, orange, violet, and green, is the fault classification. Okay, and in that B graph, I only use the craniofacial complex measures. When I introduce the airway into the system, graph A, I confirmed that in my sample I had 5 malocclusion. But it was very interesting to see that one of these malocclusion in green, which is strongly influenced by respiration and airway, it is that class 3 that I say is extremely different from the others. So, the problem that we are trying to face, so I go to the conclusion, is we would like to study the craniofacial growth in order to link not only the anatomic landmarks, but the function, respiration, the dimension of the soft tissue, and the role played by the genetics by addressing its complexity. And my opinion and my suggestion is maybe we should study craniofacial growth as a complex system. I still have 20 slides, but it's time to give the word to Dr. Esposito.
Thanks a lot.